Hi, everyone. You're welcome to another AWS London Ontario user group meetup. So it's great to see both familiar faces and new attendees just joining us today. Today's session is a topic that is becoming increasingly relevant as developers are building AI agents. We are going to explore how AWS Lambda MicroVMs powered by Firecrackers are changing the conversation by providing isolated environments. So today, we are delighted to welcome Ajay. Ajay is a DevOps and platform engineer. So Ajay, I'm going to hand over to you to give a brief introduction of yourself, and then you can carry on with the presentation. We're excited to hear what you have to share with us today.
Thank you, Cyril, for the introduction. Hi, everyone. It's really nice to meet you. And it's a really great chance for me to finally speak for our London user group. So my name is Ajay Dhungel, and I'm from Nepal. I currently live in Vaughan, Ontario, and I work as a DevOps engineer. So I have about 5 years of experience in this field, working as a cloud engineer, platform engineer, and DevOps engineer. And I'm also an active member of the AWS Community Builders program. So I've been a community builder for the last 4 years. So I'm running on my 5th year now. And today we will be talking about AWS Lambda MicroVMs. I will talk about it for a few minutes, and then we will also jump to a live demo where I will show you how we can use MicroVMs as a sandbox environment for our Cloud Code coding agent to run its code. So moving on, so moving on, what are MicroVMs? So basically, it's a new capability inside AWS Lambda. So you can rest assured it's not any kind of upgrade or replacements. So Lambda remains the same, but it's a new functionality that allows us to actually work with the Firecracker virtual machines that have always run these Lambda functions. So one of the main reasons that Lambda functions have always been so fast with the request and response model is that because they boot really fast. We have our code with the Lambda handler, and then these are actually ran by AWS with Firecrackers behind the hood. But now, MicroVMs bring that same Firecracker to the surface, meaning that we actually now have control. So we can create these virtual machines that are actually really minimal and fast. And it's no more request and response only, meaning that AWS is finally giving us a chance to use them for ourselves for a dedicated use cases, right? And these micro virtual machines, as the name says, are very lightweight compared to traditional virtual machines. And because it is lightweight, the boot time is really, really fast. And so comparing it to a traditional virtual machine, there is no BIOS. So the bootloader is very minimal compared to the traditional virtual machine. And it only keeps what we need, like a network and disk, and that's it. Because traditional virtual machines, it is replicating a fully working personal computer with your drivers for keyboards and mouse and graphics card, and we really don't need that. And because stripping out all of those makes our virtual machines really light, and that allows a boot time of about 125 milliseconds. So why MicroVMs and why now in 2026? We really thought we have everything figured out in terms of compute, but there's always been a trade-off. So if we went with a traditional virtual machines, it really provides a strong isolation. Let's say if we want to run our code in an environment isolated from something that is vulnerable. So going with virtual machines, it does provide isolation, but the boot time is really slow. And containers provide really good isolation, but as we know that containers and the container runtime, they share the kernel with the host machine. So there's always a chance of running untrusted code, and that might interfere with your host machines. And Lambda functions are fast and isolated, but they have been capped at 15 minutes. So if we needed something to have a persistent session, that would also rule out Lambda functions. So micro VMs provide all these three together. They are isolated. So they have their own kernel and they are fast. Like I mentioned before, the boot time is about 125 milliseconds. So it takes about 2 seconds to run your entire code and start the virtual machines. And that is kind of crazy. So moving on to the next slide. So micro VMs provide us this image and launch model where we can create an image out of our applications along with a Docker file. And then we zip it up and upload to S3. And then Lambda builds this image for us. Now you might say, how is this different from a container? The main reason we're using Docker file here is that it already provides that script of having your base baseline where you want to run your code, what packages to install, and that makes it really easy because there's no reason to reinvent the wheel, right? Because Docker files has been a really good standard on having a certain script that has everything pre-packaged. So micro VMs already use that. And once we have our image and a runtime inside a Firecracker VM, not a container runtime, micro VMs then take a snapshot, and then every micro VM that we launch is launched from that snapshot, and that actually allows it to have everything running in less than 2 seconds if we were to spin up a micro VM. And let's move on to the next slide. So AWS actually introduced this micro VM technology for one main use case, which is AI coding assistance. Nowadays, everyone has been using AI coding assistance, whether we like it or not. And that poses a threat, meaning if AI is writing a code, then it is writing thousands of lines per second. And there's no way that we can actually go through every line. So we might have to run it sometimes without actually reading it all. And that poses a threat to our environment. So what we want is a different environment that is safer for us to run that code, right? So a dedicated environment for any kind of code to run, and usually that is untrusted. So the other use cases I found is that we can actually use this for notebooks. We know that sometimes we want to go back to a notebook and it takes a really long time to reload. But micro VMs allows a state called suspended, where we can suspend a micro VM and then continue from there without incurring any charges. And in terms of security and vulnerability scanning, let's say we have to scan some files that might pose a threat. We don't want to look what is inside in our own environment. So if we want to do some research and see what it is all about, then micro VMs provide an isolated environment with a very small isolate like a radius, and that is actually safer option. And another option is multi-tenant CI/CD. We know that we had built CI/CD pipelines with EC2 as runners, but sometimes those EC2 instances they take a lot of time, and that increases our CI/CD deployment time. But with micro VMs, it is isolated and it is risk-free and it is faster. So a CI/CD pipeline deployment in a micro VM also is a very good option. Moving on to the next slide. So these are the 4 states that our micro virtual machines can be in. Pending as in once we call the run micro VM command, it reaches a pending state for a really short time. And after that, it is up and running. This is where the traffic is served and that the compute charges are actually applying. But let's say if we want a break, but we also want to keep the session, then we keep it in the suspended state. But if we're done with it really, then we have the option to terminate it as well. And this suspended feature is actually kind of cool because it can stay there as suspended without incurring any charges. Um, so now we will be doing a short demo. And so this is the agenda for a demo. And before getting started with microVMs, we need a few things. So these are the IAM roles and the S3 buckets where we will be uploading our zip code. And then we will build a custom microVM image from a Docker file. And then we will launch a microVM. And because the microVMs, in this use case, I'm using a Flask server and we will be sending requests through HTTP. And we will also see how we can generate auth tokens for that request to make it safer. And once the microVM is up and running, we will try and install some package and reach all those 4 steps that we were talking about earlier. So let me go to my IDE here. So this is the Docker file. It's a really minimal Docker file, and it uses base image from AWS itself, from the public ECR repository. And then we're installing Python and Flask. And then we have a server.py that serves an Flask application on the port 8080. And I have a script here that is going to create those roles and deploy the CloudFormation template that is going to deploy an S3 bucket. And inside that S3 bucket, we will upload these Docker files and our application as a package. And we will be creating the base image of the microVM. And we will use Cloud Code as our coding agent, and then see if it can actually use that sandbox environment to run any code. So without further ado, let's see and run the setup script here. Perfect. So let's give it a suffix. So here, as we can see, it is running a CloudFormation template. So let's go over to our AWS console and see how it's going. So this is the new stack that we just launched. And the main resources that it's going to build is the artifact bucket and the 2 roles, build role and execution role. These are required to build the image and execute the micro VM. So we can see the status is create complete for the buckets and the roles. Now let's go to the console and check our Lambda MicroVMs. So this is the new console. You can see that microVMs now live here. As you can see, an image is being created. Let's go back to our IDE. So now that the stack was completed, we are now actually waiting for the image to reach a created state.
So what kind of workloads are best for this Lambda MicroVMs?
I think the main target workload is definitely like sandbox environments for AI agents. I heard that AWS actually used that use case to build this service around, because there's always been this trade-off of speed and isolation. And with this, we can now have both of them together without having to make that trade-off. So now we can see that it has actually created everything. And there's an execution role that was created. And we also have that image ARN. And we have created everything in the US East 1 region. And from this, we have created this MD file with the execution role and image ARN, right? So now what we're going to do is go to our Cloud Code, our coding assistance in the other terminal. And then I'm going to run a few prompts that I have already saved them here. So we're going to ask it to use the resource in the config.md and then launch a micro VM from that image. So we have not launched any micro VM yet. We only have an image, but we're going to see if Claude Code can actually run that micro VM for itself. I think that is a really good a use case because we want our AI agents to be able to create its own runtime of that micro VM. So let's go ahead and paste this prompt here and see what it does. So we're not relying solely on Cloud Code. I have actually installed a plugin called AWS Core. So it's going to use the AWS MCP server so that it has the context of everything. So that is really important here, so that it knows what commands to run, how to interact with AWS. So as you can see, it is using a plugin here called AWS Core. So it is going to retrieve some skills on how to use AWS and then go from there. So this is actually a much safer option rather than relying solely on Cloud Code. It's Cloud Code and its training data, because AWS is always updating its API. So it is now searching the documents here, as you can see. So when working with technologies like AWS, it is important to ensure that your agent actually has the context of how to use that technology. So it says that it is now going to launch the micro VM, and as we can see here that it is right now on the pending stage, and micro VM is pending. So it's going to now poll for, so it's going to wait until it is ready. That shouldn't take long. So as we can see, the micro VM is already running because it takes less than a few seconds. And so the first prompt worked actually. So now what we're going to do is we're going to generate an auth token so that we can actually start making requests to the micro VM. So let's, and by the way, all of these code and prompts I've used, I've already pushed that to a public GitHub repository, and I'm going to share it with you as well. So we're going to ask it to perform some, run some code in the actual virtual machines, the micro VM. And here it's going to run a script that computes the first 15 Fibonacci numbers and save them to a workspace /fib.txt file. So once again, my AI coding assistant is using the plugin for AWS, and then it's going to run some commands. It is really important to look what your coding agent is doing before allowing. So every time it is asking me, it is prompting me. So I am the human in the loop for this. So here it has acquired the token, and then it's going to now call the exec endpoint. So if we go to server.py, so this is the route that it is referring to right now. So it's the same application that we built the image out of. And now the micro VM is actually running. We're going to call that same endpoint through the coding assistance. So while this is happening, let's go over to the console and see if the virtual machine is actually created or if it is just bluffing. So this is the micro VM that is running right now. As you can see, it was created 2 minutes ago. If we go here, we can see the max lifetime here is 28,800 seconds. It was created a few minutes ago. The actual image used is the actual first version. So we haven't made any changes since. So if we make any changes and then create another version, we can do that as well. And because we are talking to our micro VM through Cloud Code through the internet, it is important to have this internet egress connector. Let me refer back to my ID and the first prompt that we used. I actually asked it to attach an all ingress as the ingress network connector so that we can actually connect to it. So let's proceed now. So we have created the token, so it should be able to make a request and then run that script inside our micro VM to perform the Fibonacci series code. Okay, so it has actually installed NumPy, which we did ask it to do. Now it will run the Fibonacci script, and all of this running is being done inside our micro VM. So it's a safe sandbox environment where we can run scripts like this, and this will not affect my personal computer at all. Now I can rest assured that no matter what kind of code it is writing, it is only going to run inside the sandbox environment. So it's going to use the same token that it created. It has the endpoint to call and it has the script. So let's see how it goes this time. So while this is running, let me show you guys the GitHub repository that I have created. So I have pushed all the code that we've seen so far in this demo. So it includes the Docker file. I have a really clean readme.md to help you follow it. The image templates that I've used, the prompts that I've used, and the application code, as well as the two scripts, one to set up everything and one to tear it down. We don't want it to incur any charges unless we keep it in the suspended state. So let's go back to our IDE. So after this is done, we're going to go through a few other prompts. So we want to suspend our micro VM, meaning we're not going to terminate it, but we are going to suspend it and then try and see if we can resume and then prove that we're going to continue from the same state. Okay, so now you can see that the script ran successfully. Now it's going to read back the same text file so that we're sure that it actually ran. So once again, we're going to make the request through HTTP. We're going to use the same token. And so this is the file that was saved once the script was run. So we're using this text file as an evidence that the script actually ran. So here you can see that all 15 Fibonacci numbers are computed via NumPy. We installed NumPy in our micro VM through our coding assistants. And I really wanted to do it through Cloud Code because this is the use case of using micro VMs through our coding assistants. We could actually have made all those requests by ourselves, but that would actually defeat the purpose of using a sandbox environment designed for a coding assistant, right? So we have executed a script. We have generated auth token. So now let's see if our Cloud Code with all the context provided by the AWS MCP server will be able to suspend the micro VM. Okay, once again, it is not running any code haphazardly. It's again referring to the AWS plugin. And then it's going to call the MCP server, get the context that it requires to suspend that VM. And once it has that context, it's going to suspend. And the result is the state suspended. Micro VM with this ID is now suspended. State, including that text file. And NumPy that we installed is preserved on disk and will be restored on resume. So let's see if that is actually true. So now we want to resume the micro VM, generate a fresh auth token, and then we're going to send another request to make sure that the session is actually preserved, because that's what we've been talking about earlier, that it is persistent session storage. So this is what I want to advocate. Always use some sort of MCP server that is official and well documented. So this MCP server I'm using is from AWS itself, and I have installed it in Cloud Code as a plugin. So once again, that suspended micro VM is back to running, and we have generated a fresh new auth token. And once that token is generated, we will be making another request to the same endpoint. So let's go ahead. So as you can see, it was able to get the same state, meaning the fib.txt file is still there. Now, if we were to do this with Lambda functions, then that would not be possible if we deleted everything. And now that we have proven that the state persistence is true, we're going to tell it to terminate that micro VM so that we do not incur any charges. So once again, referring to the plugin, getting the context that it needs from the documentation, and running the command to terminate the micro VM. So as you can see here, the states is terminated. Micro VM with this ID is terminated. All compute resource have been released. So this was a really fun demo for me because I love working with AI coding agents and any new technology that will enhance it. Now, a few months ago, I would have not using an MCP server, and that would have taken a lot of time because Claude does not know AWS the way through its training data. And because of that, and because of this plugin, even if it is not trained with AWS, it will always have that context through the MCP call. So it knows what CLI command to use. And so yeah, that's the demo for now. If you want to try it, I have the GitHub repository with me. So if anybody has any questions, I would be happy to answer them.
I see there are a few questions. We can address those questions.
Perfect. So first question, what are the biggest security benefits compared to running untrusted code in containers or Kubernetes? I mean, both containers and Kubernetes, they do provide isolation, but we're using a container runtime that is sharing the kernel with the host machine. But with micro VMs, it actually gets its own kernel. So it is really isolated better than containers. So I would say that is one of the biggest security benefit. Another question is what limitations or trade-offs should developers be aware of before adapting Lambda MicroVMs in productions? So if I would say that Lambda MicroVMs are a very niche service. So these are not, if you want to build something in production, run an application, this might not be your ideal service because it is relatively new and it is not for your bigger workload. It is only for something small that you want to run in a safer environment. So I would say that containers and Kubernetes are still the leaders in that department. So another question is, if someone wants to start experimenting after today's session, what's the first project you would recommend they build? So if you want to work with micro VMs, I would say that you can build micro VMs. You can build these images through infrastructure as code so that you can always refer it. You can always have that control. And then try and create a micro VM, try and connect it through Cell. We saw that I was using an ingress that actually used internet, but there's another connector that allows you to have the Cell connector so that you can directly access the CLI of that virtual machines of the micro VM. So yeah, definitely there's a few use cases other than just using it with your Claude Code AI assistant. So I would say that you can use that as well. And see what you can do. Try and experiment. Maybe you can find something more. And yeah, that's all I can say.
Yeah, that's true. We want to have some isolated environment, run our code isolated from what we are currently doing. So I think micro VMs really are going to be helpful in that domain. So
exactly, yeah. So we saw earlier that I have AWS CLI in my machine, right? So let's say if Claude had access to that, it would be devastating if you actually have resources in your AWS. So Claude, we have known incidents where people have actually deleted live production resources and found out later because they were only talking to their AI agents and it was the AI agent that did that. So using something like a micro VM allows you to not have that problem because it allows you the sandbox environment. So you only give your cloud code, a codex or Kiro, any AI agents that you use a separate environment. And that is the main use case that AWS has, like advocated for the micro VMs.
Thanks so much, Ajay, for this wonderful presentation, sharing with us micro VMs, making our workloads safer and more secured. We hope we can have you some other time to come speak with our user group when you're available.
Of course.
So thanks so much for joining us. And
perfect, Cyril. It's been a pleasure. Bye-bye.
Bye-bye. See you next time. Bye.
Thank you.